Welcome all of you for Unlock and Digital Electronics Laboratory. Today you will going to learn about single phase fully controlled converter. Okay, you are using uncontrolled rectifier. Single phase fully controlled uncontrolled rectifier. So let's see, we are going to go through for that one connection diagrams. So this is about the connection of that one single phase fully controlled converters. So first you can look about the circuit diagrams. So this is about the circuit diagram of the single phase fully controlled rectifiers. So here you are using uncontrolled rectifiers. So this is the connection diagrams. When you will going to give the numbers 1, okay, 2, 3, 4. So what is operation? Mode 1 diode are the D1 and D4 are conducted. Mode 2 conditions diode these two. So this cross, the next one is this cross. Multiplication I said already. So it is working like multiplication. Mode 2 condition, these two diodes D2 and D3 is conducted. So here is a load. So we have the two loads, 1.5 kilo ohm. The next one is a 2.2 kilo ohm. So we will going to measure the connecting the load and measure the V0 and I0. So connected across 1 voltmeters. So you will going to measure that voltage, measure the value, and here you will going to connect it one seriously with 1 ammeters. You will going to connect it. You will going to measure the I0. So now I have connected 1.5 kilo ohm. So what about the yes. So you can look at that one output voltage. So connected across to the resistance, I have connected across the resistance. Output voltage is a 7.42 voltage. So here you can note down 7.42 voltage. So 7.42 voltage is across the voltage drop across this 1.5 kilo ohm. Then what is the current? You can see the current. So 4.98 milliamperes. So here I have mentioned about the milliamperes. So 4.98 milliamps. So you will going to write about the milliamps. So otherwise in top you will going to write the milliamps. So 4.98 you will going to do. So here you will going to. So here you will going to connect it for the digital. Okay. Differential module you will going to connect it. So input of the differential model and output of the differential model. This differential module get that one from CRO. So CRO is connected. Okay. In that CRO input probe and the output probe. So you have see that once. So directly I said about that one last class. So you should not be directly connected to that breadboard. So because. So what will happen? So you can't get it under the clear output result as well as isolation problems. That's why you are going to use for the one differential module. So take this CRO probe and connect it to here, and this is the input side. So I got connected this to probe across to the input of these two terminals. So where is the input? So here is the input. So across you will going to connect it for the probe, and then output of the terminal is this is a probe. You will going to take it on that one. So you will going to connect it across to that resistance across. You will going to connect it. So now you will going to see that waveform. So here you will going to see the waveform, input waveform. So what is the input waveform? Sinusoidal waveform is you will going to get it on the sinusoidal waveform. It's a fully control converter. The output waveform is, what about the output waveform? It is a full wave. Okay, full wave waveform. So off cycle, negative off cycle also rectified. So you will going to get. So like it is the output waveform. When you will going to move the variation, see output waveform is this is the output waveform, input waveform. Okay, so this is about the fully control converters waveforms. Okay, so I will going to make you for that disconnection as well as the connection of that ones. So here is a. So now you will going to learn about that ones. So first one you will going to coming to know that one. So one anode and cathode, this is joining point, anode and cathode joining point. Across these 2 points you will going to connect it to the AC power supply. Cathode is a point you can connect it to the ammeter. Anode point is you can connect it to the resistance. So now you can. So now you will going to see that one. It's already connected diagrams. So now I will going to disconnect. So first I will going to disconnect the source. So source is I have removed. So once I have source is removed, so your meter is will going to source as a 0. So then I will going to remove for that all the probes. All the connections I will going to remove. Okay. So now I have removed all the connections. So this is the input of the probe. I will going to keep it on the separate. The next one is this two is the output of the probe. So neatly you can going to keep it on that side. Okay. The next one, you have look here. So this is a voltmeters. So voltmeters, two terminals is there. Okay. This is a ammeter. Ammeter, two terminals. Okay. I would like to interchange the another wires. Some loose connection is there. So whenever you will going to do the breadboard, so you should be conscious for that proper of the wires. So here is a ammeter. If you have consider ammeter means you always should connect a common. Another one is a milliampere or ampere. So I am using the milliamperes. And then position position, it is also very important. So now let's you can come to that breadboard connections. See that one. So this is the basic connections I made. How I made it that one, you will going to see the circuit diagram. So anode and cathode is joined. Anode and cathode is joined. Yes, see here. The first one anode, okay, and cathode point. This cathode point is another one is joined. So like I have joined. See anode and this is anode. So this is end of the cathode. So end of the cathode is connected to the anode. So connected to the anode. So like I have joined, this is another point. Similarly, anode, this is a point. Okay, this two anodes I have make the short circuited. Yes, I have connected. So these two anode is shorted. Okay, anode, another one is another end is a cathode. Cathode is connected to the anode point. Okay, this okay cathode. Okay, this cathode is shorted. So now like the circuit diagram is over. Then where is the point? The joining point. Anode and cathode joining point you will connect it to the AC power supply. So take that AC power supply. You will going to connect it here. Anode and cathode joining point. Here also anode and cathode joining point. So once you are connected, this is the part is over. The next what you will going to connect it. Now I would like to go for that one resistance. Low. Okay, before where is that one resistance? There is another one resistance. Okay, here. Okay, now I would like to go for the 2.2 kilo ohm resistance. So how it is connected? The cathode terminal is connected to the one ammeter. Yes, ammeter another end is connected to the load. So ammeter another end, this is ammeter another end connected to the load. So load, okay, another end I have connected to these points. Okay, from this point, so load is connected to the anode means the circuit, entire circuit is over. Okay, so once I have connected, see there you will go to okay ammeters. Ammeter is showing the reading of the 3.39 milliampere is showing. Once I have connected ammeters, so next one I will going to connect the voltmeters. So voltmeter is connected across to the loads. So this is a here see you have the two terminals. This two terminal is connected. One is connected to that load one end I have connected. Another end is you can connected to that. Okay, connected to that load another end. Okay. So once I get connected, you will going to see that once. So the reading is showing on that once. Okay. So now you will going to note down the readings. So coming to here. So what is the voltmeter? 7.47. So 7.47 is coming. 7.47. Okay, voltage. Okay. What about the current? 3.4. So 3.4. So milliamps I have written commonly. So your tabulation is over. That's all. Next you will going to see about that connection of the CRO. So when you are connected input side consists of the two terminals. So take this one. So connected across to the AC power supply point. Okay. So here I have connected at the one end. Another it does not consist of any polarity. So once I get connected, you see the CRO. So CRO it will going to produce the sinusoidal waveform. The next one I will going to connect it the output waveforms. So I need an output probe. So in that output probe I will going to connect it across to the load. So load one end I will going to connect it here. Load another end I will going to connect it this point. So once I get connected, you can see the waveform. So you will going to see the waveform. So you will going to get it on the DC waveform. You will going to full waveform. You will going to get. So this is about that single phase fully controlled converters. So just one second, you will going to look the circuit diagrams, tabulations. So circuit diagram it will going to show you for that is single phase fully control converters, and then I have varied with respect to the variation of the load. So load resistance I have varied 1.5 kilo ohm, 2.2 kilo ohm. So when you will go into variations, so voltage and current and voltage and current, whenever increase the load, what will happen? Automatically the current values also it is reduced. So whenever load is varying with respect to the current, it will going to dependent, that is a factor it will going to dependent. So load variation automatically much variation of the current. So that's all about single phase full wave uncontrolled rectifier. Thank you.